Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. I'd like to start out by thanking everyone who joined me last week at the TWiML AI Summit in Las Vegas. It was a great event. For a summary of the event and my key takeaways from each of the event sessions, sign up for my newsletter at twimlai.com/newsletter. I wrote about it right after returning from the event last week, and when you sign up, you'll automatically get an email telling you how to get access to back issues. Again, that's twimlai.com/newsletter. Event season continues this week. Tomorrow, I'm keynoting at the Prepare AI event here in St. Louis, and then making my way out to San Francisco for Figure 8's Train AI conference. The Train AI agenda looks awesome, and I'll be on site all day podcasting, so if you're in the Bay Area, you should definitely plan to stop by. Of course, if you do, use the discount code TWiMLAI for 30% off of registration. Be sure to give me a shout if you're planning to be around. In this episode, I'm joined by John Bohannon, Director of Science at AI startup Primer. As you all may know, a few weeks ago we released my interview with Google legend Jeff Dean, which, by the way, you should definitely check out if you haven't already. Anyway, in that interview, Jeff mentions the recent explosion of machine learning papers on arXiv, which I responded to jokingly by asking whether Google had already developed the AI system to help them summarize and track all of them. While Jeff didn't have anything specific to offer, a listener reached out and let me know that John was in fact already working on this problem. In our conversation, John and I discuss his work on Primer Science, a tool that harvests content uploaded to arXiv, sorts it into natural topics using unsupervised learning, then gives relevant summaries of the activity happening in different innovation areas. We spend a good amount of time on the inner workings of Primer Science, including their data pipeline and some of the tools they use, how they determine ground truth for training their models, and the use of heuristics to supplement NLP in their processing. All right, let's do it. All right, everyone, I am on the line with John Bohannon. John is Director of Science at a startup called Primer. John, welcome to This Week in Machine Learning and AI.
Hey.
So this conversation is an interesting one. It grew out of a listener response to a comment made in my recent interview with Jeff Dean. Jeff commented on the explosion of machine learning papers on arXiv. And I jokingly asked if Google had already developed the deep learning-based summarization techniques to help us all keep up. And it turns out that one of your colleagues, John, reached out to let me know that you have been working on this and have built it. And actually, just before we got started, you showed it to me, and it's pretty cool. So here we are. But before we get into the details of that project, you've got an interesting background in molecular biology and data journalism. How did you find your way to AI?
It's a long journey, but I think it started in computer camp when I was 9 years old. So that's the kind of summer camp I went to. And as my studies progressed, I actually drifted away into biology. Did a PhD in molecular biology, and then before doing my next postdoc, I wanted to take a break and do something different. So I tried being a journalist, a science journalist, and fell in love with it, and basically jumped off the academic track and became eventually a computational journalist, basically using data and code to find and tell stories that are impossible to tell otherwise. And a friend of mine named Sean Gorley, who did his PhD with me in England at the same time. We actually lived in the same house. Our fate eventually became intertwined again. I moved to the Bay Area to do a visiting scholar stint at Berkeley, and he's in San Francisco. He says, "Hey, John, I've got this startup called Primer, and you really should come by and check out what we're doing. I think you're going to find that the stuff we're working on really, really matches with the stuff you work on." And so eventually I had some time, and I was like, okay, I'll pop over there for a week. And sure enough, within one day, it was clear that they were solving problems that I just find so hard and I wanted so badly to solve myself that basically if you can't beat them, join them.
Nice, nice. So maybe for context, you can tell us a little bit about what the company does and the kinds of problems that they're working on or you're working on.
Yeah. So Primer at its core is an AI company that's trying to make machines that read and write. That's the fundamental problem that underlies all this. In terms of a business model, we, for example, automate a lot of the work that a junior analyst would do in, say, a bank or the intelligence community. Also, frankly, what a journalist does. I feel like I'm reverse engineering myself every day because a lot of what you have to do, actually, it's also somewhat automating a lot of what you do, Sam. Like all of our jobs, what we have in common is that we have to read a ton of stuff, often very technical stuff, and make sense of it, and then tell stories. That is the fundamental unit of information. That's our data structure,
right?
A story, and that is really hard for computers to do.
It's really hard for people to do.
Exactly. I think, yeah, it's one of those things that's hard for everyone. So
I think you're relatively new to this podcast, but those that have been around for a while or from the beginning know that it started out as more of a news-oriented format as opposed to an interview format. And basically, my mission was to kind of summarize the most interesting AI and ML tidbits from the previous week's news. But that is super, super hard, especially with so much news happening all the time. It would take a ton of time to curate all of that information and digest it and, turn it into stories, as you're saying.
Exactly. And so you face several problems. And what we're trying to do at Primer is break it down into reasonable problems that you can actually attack. So one is for example, what's relevant? What are you telling a story about? It's not enough to just say, I want to tell a story about last week's AI research. It's like, okay, well, what documents are relevant? Even if you could get the papers, then it's like, well, where do you get all the conversations about those papers? How do you figure out what those papers were about? If there were 1,000 papers published over the past several months and you wanted to tell a story of 1,000 papers, I don't know how a human would do that. Well, actually, I can tell you, humans simply don't do that. What we do is we take shortcuts. Mm-hmm. We sort of fly blind. We grab, the zeitgeist, and that's kind of a random process. It's like, well, I overheard some conversations, and this seems to be a hot topic. I'm going to decide, and so I'm going to amplify it. And what you end up with are coherent stories, but they're not necessarily what actually was the most important thing that happened. It's just some strange sampling of the space of all things that happened. And that's the best you can do. But what if you had a machine that could actually read everything and show you, in some sense, everything that happened? That's the goal.
So you showed me kind of a portal into research papers. Is the idea to provide that as a service or more the platform that allows someone to create that thing?
So we're in a pretty privileged position. We're privileged in the sense that we've already got some really big customers. So the federal government, Walmart, Singapore's Sovereign Trust, several others coming online soon. Those are the relationships that actually pay the bills. And so we do things like if you have a portfolio manager who's trying to keep track of a ton of companies, that portfolio manager needs to stay on top of all the relevant developments in the space roughly defined by all those companies, all the news about them, maybe SEC filings, if you want to assess changes in risk profile. It's sort of an overwhelming task. And so Primer basically superpowers those analysts by automating all the things that are really hard and tedious and time-consuming, and it basically reduces the cost of curiosity. It allows those analysts to not spend half their day reading a million things just to find out what was worth reading. Instead, they can see summaries of 100 papers at once, get a sense of whether it's worth diving deeper, or look at another batch of 100 papers. It also gives alerts with predefined conditions so that you don't lose a second if something that you know in retrospect is going to be a situation worth knowing about. You'll get a heads up. So meanwhile, though, you can use the same machinery that does reading and writing and summarization to do things like the thing I sent you, like read all of archive. So we do have a business model for this system going forward. We're going to be developing it into products for example, the pharmaceutical industry. But for the time being, we just have this beautiful laboratory where we get to really push the edge of natural language processing.
Tell us more about this archive project that you've built.
Yeah. Archive is a really good illustration of this problem that we all face of too much information. If you ever go to the archive website, you basically see a fire hose of research coming in. Archive is amazing because it is literally the place where research gets debuted. It's the first place you'll see a paper coming out from Google or Microsoft or MIT on topics that are basically going to define the machine learning progress over the next 10 years. In retrospect, you can look back and you can see the timeline of this amazing scientific revolution unfolding. But it's not at all human readable. Like, even if you are an expert, even if you have a PhD in machine learning, you just can't make sense of all of archive. You might be able to make sense of the papers in your own subdomain, but even there, it's tough. You got to find them. Archive isn't designed for humans in a way. I mean, it is, but it's just not user friendly. Mm-hmm. And so, Primer Science is a stab at making sense of that. Basically, it's a really hard problem that's well scoped. So, what it does is it harvests all these papers, and it does unsupervised learning on the content of the papers to try and figure out what are the topics that this naturally falls into. So within machine learning, for example, I'm just looking now at some of the latest. The system has discovered that there are not only image reconstruction papers, there's like 58 papers actually in this bag that are on that theme, but it has discovered that there's a whole bunch of research on traffic and temporal analysis. There's something on mathematical optimization. There's a whole bunch of papers about semantic segmentation. So all of this is happening without an ontology or a knowledge base. And you're going to have such a system if you want it to work on any corpus of papers. So you could imagine building some super ontology that captures everything there is to know about science. But then it's going to be out of date next month. Like, I wouldn't want to build that thing because, maintaining it would be a nightmare. Instead, you need a system that does more or less what humans do on a smaller scale. What we do is we look at things and we just sort of eyeball it and say, oh, these are kind of about this and these are about that. And so you get a natural segmentation of the space. And then within each of these topics, it does a time series analysis and it tries to figure out if I take all the news and the social media signal, all the tweets about this research as it was published and afterwards, all the commentary, all the sort of real-time online critique, sort of the peer review that's happening in real time out in the open, can I detect events? And so an event can be more than just the publication of a paper. It could be that, for example, a self-driving car crashes somewhere, and suddenly the world is looking intensely at an issue related to what we do and don't know about these systems. And some of this research may get pulled into that. If you want to detect that real-world event, you need a system that can actually divide all those documents, all those tweets, all those things that are relevant to the same thing and figure out how to segment them in time. And so it does that too. It tries to figure out essentially what were the big events in this space? How was human attention in the world divided in relation to this corpus of papers? And then it does some other cute tricks to make it useful to you as you dive into all of this information. It pulls out all the people and tries to tell you what it knows about them, just based on the corpus, mind you. We're also developing a version of this that is building a knowledge base and actually learning about people as it reads the news and as papers are published. But what I sent you this morning is just essentially the out of the box. I don't know anything about the world, but I know this group of thousands of papers you sent me, and this is what I can tell you about them. These are all the people. These are all the topics. These are the events that seem to, all of this information seems to be pointing at out in the real world. And another cute one is if you're finding the jargon really hard to understand, I've generated a dictionary for you that is kind of a magical dictionary where if you click on a technical term, it actually shows you who coined that term, how is it defined? Give me some context about how it's used. It's kind of like a Oxford English Dictionary on steroids.
Nice. I'm finding this interview more challenging than most because as you're speaking, I've got the tool in the background, and I keep seeing papers that look really interesting.
It's working.
Super, super distracting. So maybe can you tell us a little bit about the technology that's making it all happen?
Yeah.
What does the stack look like? What does the pipeline look like? How are you approaching the unsupervised learning piece?
So it all begins with a gigantic Elasticsearch index.
Okay.
I think if you talk to a lot of the people that you've interviewed, even already, about what's at the bottom of this whole stack, there's often like some massive index of documents. Mm-hmm. So we're ingesting the news and blogs and tweets and scientific papers every day. And that's the starting point of this whole system. And it has this growing corpus. And so if you query, as we've done today on artificial intelligence, for example, the first thing it has to do is retrieve all the information that is relevant. And then kicks off this pipeline where basically the first thing it does is it tries with unsupervised learning plus several other steps to divide all the information up into natural topics. So within each topic, it then tries to detect the events in the real world that any of these documents might be referring to. So if you've got like 100 documents that might be news documents and scientific papers and social media signal about all the above, you do a time series analysis on it and you try and figure out are there real world events? It's trying to make an inference here. Are there real world events that all of this information is pointing at and describing?
It looks at events basically from the perspective of news articles. Is that right?
The system you're looking at does, yeah. But you can imagine any document that has a meaningful publication timestamp and includes a description or commentary about something that happened in the real world. It could, in principle, be mapped to something called an event. Okay. The concept of an event is bigger than what a human intuitively would call event. It might actually be, for example, an explosion of discussion around an issue. For example, the Me Too movement is not just an event, right? It's made up of many events. Right. And some of those events might not even be something that could have been observed in one place at one time. But there is a natural segmentation of all the things happening in the world into something that we call events. So that's the theory behind this. Then if you click over to overview, sorry to distract you again. Then it tries to tell you a story. So we've got many versions of this. What you're looking at is basically the one of the earliest versions of this. But basically, if you asked a machine to go and read thousands of things, and you give it a budget of 1 page to tell you what it learned, this is starting to get at what you'd expect to come back. This is what you get. It's basically, and it's kind of like a technical report on these are the things that I learned. Here, these are the big events. These are the big papers. This is what's getting the most attention. Oh, and then by the way, my topic analysis has revealed that there are some changes afoot in artificial intelligence, and these are the things that seem to be trending upwards and are really interesting. And oh, by the way, I discovered there's this weird paper that seems to fall in this topic, but it's deeply connected to this other topic, and that's statistically strange. I need to tell you about it. And by the way, here's some people who seem to be getting a ton of attention, and here's another person who has collaborated with them on a high-profile paper, and they've never worked together before. That's interesting. So you can see what's going on here is the system has a model of what humans find interesting. And of course, we humans at Primer built that in. There's a story logic that underlies this. You don't want a system to tell you everything it learned. It's just going to be another fire hose. You've made no progress. A one-to-one map of the world is not a useful map. So you need something that will compress the information and try and tell you a story. So that's what the system does.
I think I interrupted you as you were about to start talking about the pipeline that you're sending some of this stuff through. And just going back to the beginning with archive, like, are you ingesting all of the archive papers or crawling that site? Like how?
Yeah. So Paul Ginsparg, who founded and still runs Archive, is a friend of mine from a good while back. And he uses Primer Science as well. I think actually he's the very first one I made a user account for.
Oh wow!
Yeah, and so he's really helped out over the past year, making sure that we have direct access, so we don't have to scrape the site. We basically just pull down the entire day's new papers all in one go, and we do the same with news, except it arrives more or less in real time. So we have a real time stream, more or less, of the news with maybe a 10-minute delay, and we've got a real time stream of all the tweets that are relevant to the space.
And are those via commercial APIs of some sort?
We get them directly from Twitter.
Okay.
So yeah, we have a data deal with them.
Okay. And the news?
The news we actually have several sources of. One of the most convenient is LexisNexis. They have a service called Moreover. You can actually purchase a fire hose of news. They do a really good job, actually.
Oh, wow. Okay. So you pull all that into your Elasticsearch index, and maybe talk a little bit about some of the underlying NLP bits that are enabling all this.
Yeah. So when you kick off a query, what's happening is you're making a lot of reading happening. So, for example, if you take a look at the topics that have been generated, text and word embeddings, quantum, and all of those topic labels that it's generated, it actually discovered and chose those from the content of the articles themselves. So the first step in any NLP task on documents is to tokenize the entire document. So are you familiar with tokenizing?
Mm-hmm.
Yeah, so you basically discover all the words and punctuation, and you run an analysis that gets you the parts of speech. It's kind of like what you did in grade school when you made these sentence diagrams to try and make sense of all the different parts of what someone says. And then a whole bunch of things happen in parallel. Basically, you have to. There's some things that are useful if you give it a bag of words. So you can take an entire scientific paper, or even 1,000 scientific papers, and they turn into bags of words. And with that kind of analysis, you could, for example, discover the groups of words, the n-grams, that basically best describe the space. And you can generate a label. So if you go into any of those topics, it has decided to give that topic a name based on the language within the documents themselves within the topic. So I'm still amazed that it works, frankly. NLP is kind of magical. When something makes sense to a human, when there's a machine that didn't really understand it in the same way you did,
right.
It's kind of magical.
Are you using kind of off-the-shelf NLP toolkits, NLTK Python stuff, or are you kind of rolling your own stuff?
No, we started off that way.
Okay.
So we've been using this tool Spacey from the very beginning. It's free, it's open source, and it's really powerful. It's really, what shocks me is that there are just two people at the heart of this project. A fellow named Hannibal and a gal named Ines, who live in Berlin, not far from where I lived for a few years. And I've gotten to know them a little bit just recently. And it does the nuts and bolts NLP that you need. So it will tokenize, but it'll also discover named entities. It'll help you find the people and organizations and so forth. But you need to train it. That's something that we have discovered is just probably like everyone else. It'll get you started, but then you need to solve your own problems. It's only a starting point. So, for example, with the people and all the information that we can extract about them and tell you a story based on the people in this space. Spacey is one of the things that we use early in the pipeline, but then there's a ton of custom code that we had to build to basically get the kind of information that Spacey can't get, to clean up the stuff that Spacey gets wrong, to link it with all the other information we're extracting by other means. And it's a mixture of machine learning and good old-fashioned regular expressions. What I find so fun about being at an AI startup is the goal here is not to generate research papers. The goal is to just solve problems really well by whatever means you can. So, which I think is like the right motivation to have.
Right.
If you're just motivated to publish cutting edge papers, you don't care if it works. Like I went to this conference called Nibs, which is essentially like where all this cutting edge research is being debuted.
Mm-hmm.
And something that really struck me is like half the stuff that people are bragging about doesn't even really practically work.
Or works within such a narrowly constrained.
Yeah, exactly. With a toy problem, it'll work.
Right.
But it's like it's computationally intractable or whatever. And that's fine. It's like that's the whole point is to debut tomorrow's technology. But it's frustrating when you're trying to build something and you get excited about some new idea and you chase it down only to discover, oh, this actually never could have worked.
Yeah.
And I've had that experience. I found a paper using primer science, of course. It's a pretty weird situation to have AI eating itself. We basically have an AI system that reads AI papers, which we then use to try and improve the AI that reads the papers. But we came across a really exciting paper and fully replicated it, and it just doesn't work. And that's okay. That's how it goes in this space. When you're right at the edge of knowledge, it's not all going to work. So we have this principle at Primer of always trying to find the practical solution as quickly as possible. Don't get seduced by ideas that are sexy to talk about, but it's not actually solving your problem.
Yeah. I should throw in a plug for my newsletter. I've recently written on this topic of reproducibility and both science and AI, drawing off of a recent interview I did with Claire Galnick on this same topic. But I really appreciate you, owning up to that broader pipeline. One of the questions I get a lot when talking with folks about their products or projects is, people want to know, like, okay, granted, you've applied, some great cutting edge machine learning AI stuff, but what else is there required to make it work? Like, how much heuristics are kind of in and around these tools to actually make it work? So to hear you note that, good old regular expressions are used liberally to, make sure
Absolutely.
that this all works. I think it's important to realize that. And
Oh yeah, absolutely. I guarantee you go into some of the biggest, most cutting edge groups at giant tech companies. You'd think that they're doing some kind of pristine AI that you just press a button and it understands things. I guarantee you look under the hood and there's just a ton of regular expressions. Now, that's not to say that machine learning isn't the way forward. Like, it totally is. But to make these things work on actual problems, it's still a labor of love.
So you're doing a lot with Spacey. Are you also, which I'm assuming is more traditional NLP technology approach, are you also doing things with like Word2Vec and deep learning based approaches?
Yeah. In particular, as we've expanded into other languages beyond English, Spacey is just not going to cut it when you want to make something that understands Russian and Chinese. So we've actually had to pretty much make a bunch of tools from scratch, but it relies on word vectors and word embeddings, and where things get complicated is actually where you try and pull this all together. So if you use deep learning to extract, for example, some pattern in a corpus of 10,000 documents, the harder thing, once you've extracted it, is knowing whether you're right and whether it's worth saying. Like, I can find a bunch of patterns in text pretty easily, but the harder thing is assessing how confident am I that I've found something that I haven't just misextracted. It's not just a spurious pattern. And then even harder than that, is it worth telling you? How do I square this with my model of what humans are interested in?
Right.
So where we're headed with this is basically a model of stories, which ultimately is a model of humans. Humans are storytellers. We've evolved to do this thing. And we just take it for granted. Like, what we're doing right now, this conversation is incredibly high tech. Like, you and I in real time are like gliding through a narrative that didn't
millions
exist.
of years of technology evolution.
It's amazing. Yeah, it's amazing. So I think this is actually the next frontier of AI. Decoding what story is.
Yeah. And so what does that mean practically? How are you approaching that?
Yeah, so here's a bite-sized example. If you make something that reads scientific papers and tries to tell you what you need to know about AI research last week, for example, it's not enough to just give you a dashboard of here's the most shared paper, here's the paper that got the most news, here's the paper that currently has the most citations. That's not doing much heavy lifting for you. If you were to hire 1,000 human analysts to just work for you, like, imagine you had that luxury, what would you ask them to do? That's kind of the better guiding question. And what sort of story would they tell you? What would the format be? I guarantee the humans wouldn't come back and give you a dashboard. They would say, okay, the big deal last week is that a self-driving car crashed, and it's kicked off a huge discussion about quality control and where system errors are going to creep in, and how you can make machine learning systems understandable, like from an engineering point of view. How are we going to deal with this emerging problem? And the people who are weighing in on this are the following researchers in deep learning, but here's some other people who are very knowledgeable, but they're in an adjacent domain. And we think this is really worth knowing. But meanwhile, by the way, we discovered a paper published by a couple of researchers that you've rarely heard of, but it's getting a lot of traction, and it seems to be on a topic that is emerging, and you're probably going to care about this. It's basically, it has to do with voice recognition, and we know that that's an interesting topic. But the more interesting thing is that this researcher is really well known in a totally different field and is just like diving into this, and that's unusual. So check it out. Like, here's the paper. I'm just going to go out on a limb here and say you really should read this paper. And then, by the way, like here's basically a new concept that is creeping into the space, and we haven't seen it before. This might be a fluke, but I think this is actually something that's worth knowing about. And so here are 5 papers that you should read. I'm working within your budget here. So that's what all the humans would do. It's basically the kind of like 1 to 2 page presidential intelligence briefing. That ideally that's what it would look like. A ton of research has gone into boiling things down to a very tight story, and that's all you need to know. And
so the idea then is that you've got some kind of generative model for creating these, basically your briefing overview.
And it has 2 steps. Like at least 2 steps. One is, what information can I find that's truly relevant? The raw ingredients of a story. And then the next step is, well, how can I synthesize this into an actual story? I have to do text generation, document planning. You give me a budget, a page, a paragraph. Maybe you just want a bullet point, and I'll work with it. I'll be able to express this as a story, given that constraint.
And so kind of going back to our earlier exchange about, good old-fashioned heuristics, like to what degree, I haven't looked at, compared one of these briefing pages versus another, but, how much is generation and how much is, more, like templates and things like that?
Mm-hmm. Yeah. So the philosophy we followed is always start fast and doable. I mean, put another way, like you always want to start with a model that you can fully understand yourself and implement quickly, so that you have some baseline.
Sure.
So we've always started with first, can you do it yourself as a human? Maybe even no computer involved. If you were to read 10 papers and try and say something intelligent about them, for example, tell me, for example, what if you were to classify events, and I gave you a pile of papers, and I said, how would you classify these events? What kind of tags would you attach to them? Or if you were looking for a particular kind of event, could you divide papers into yes and no? Always start with yourself, you the engineer. Can you yourself do it? Because if you can't, you're probably going to have a hard time teaching a computer to do it. And then if you get some other humans, probably the person just 2 chairs away from you, if you can get someone else to do the same task independently and get the same, ideally, or a similar answer, okay, now you're in good shape. Only then do you start building a computational system to try and do this automatically. And your first stab at that should be something straightforward, a set of regular expressions, heuristics. Can you actually find this yourself using rules that you yourself devise? And then, if the only way really to get beyond that, to really tackle increasing complexity, is to have something that will learn on its own. You'll never do that with regular expressions. You have to use machine learning to have a system find patterns itself in a changing world.
So I think you're saying then that there's, you're somewhere on the spectrum of templates and machine learning.
Oh yeah, always. And in fact, I think the best things out there are always somewhere in the middle.
Right.
I think by definition. Yeah, and essentially it becomes a race. Can we build something that can learn faster and output better, smarter content than the system we have? We had a little race actually recently to try and build an event classifier, and a brilliant engineer named Leonard Appleton took a stab at just using regular expressions, no machine learning. And another brilliant engineer named Yash took on the task of solving the same problem using a really complicated machine learning graphical model. And sometimes John Henry wins the race. Frankly, Yash could not build a system, at least last I checked, that could do better than Leonard's massive, complicated regular expression heuristic engine. But eventually, machine learning will win. Like, we all know that.
Right.
But that's the beauty of a practical approach. When you're really driven by practical principles, you're willing to say, well, we've got a better solution that's actually simpler and easier to understand. Let's use that for now. Keep trying. But it's never long before a machine learning based system does better. It's just an incredibly powerful tool.
When you're using machine learning for tasks like summarization, where you referenced earlier, first you do it, then you get someone else to do it and you compare them. Your summary of a given paper or a given paragraph is likely to be very different from mine. Like, how do you find ground truth so that you can train learning models?
Yeah, that you've really put your finger on the hardest problem. Stories, by their nature, can be told infinite ways. And there are some automated techniques that have been around for a decade. They have French color names. I don't know how that came about, but there's something called rouge and there's something called blue. And what they do is they treat the output as bag of word problems, and they try and find out how much information overlap there is between a human summary and a computer summary. As you can imagine, that's great if you're trying to measure whether you got it terribly wrong, right? If we make two summaries and they have nothing to do with each other, then they're probably not talking about the same thing.
Maybe.
So, that's right.
I mean, if we're summarizing fiction, right, we could be summarizing on two totally different levels and both be right.
That's true. That's absolutely true.
I mean, the same. I think the same holds true for news. I mean, I'll let you continue, but that seems like a very, very rudimentary metric.
Well, I mean, you'd be surprised then to learn that the latest, greatest papers in this field are still using those metrics because they're easy. You can. It's a one-click measurement,
right? Right.
But it really doesn't help when you want to assess a subtle output of a story that could be sliced and diced sort of infinite ways. Unfortunately, it becomes a CAPTCHA. You need some human to read it and go, "Oh yeah, that makes sense," or "That's crazy."
Right.
But there are some techniques you can use. So one is you can actually crowdsource assessment of narrative. You can give human annotators and scorers a system, a rigorous system. So like you can measure the coherence, you can measure the sophistication, whether or not you've really summarized the space well in various ways.
Those sounds like they would require a fairly sophisticated crowdsource.
Yeah, so that's right. Like the more technical and sophisticated this task becomes, the less you can rely on Mechanical Turk. In fact, eventually you've got your own engineers doing this, so it's definitely not scalable. But there are some tricks that you can use. So, for example, if I generate a bunch of summaries on a topic that I've already summarized, for example, if I have a Wikipedia article about it, I can at least find out if the most important entities in the narrative have been represented. And I can also turn the system around and do extraction on the summary. You can even, I will suggest, to make a generative adversarial network that generates stories and critiques them. Mm-hmm. You can see where this is going. Mm-hmm. Eventually, you can have a system that tries to check off all the boxes of what counts as a good story, like you've talked about the most important entities and you've expressed their relationships. You've come in under budget in terms of space on the page. But ultimately, you're going to need a human to assess whether it's a well-written story. Until we can crack the code of text style transfer, where you can actually say, tell me this story in the style of a New York Times reporter, or tell me the story in the style of a terse military briefing document.
Send out my text in Hemingway style.
Exactly. Until we can actually have networks that can both detect and reproduce narrative style, I think we're for the time being stuck in a world where it's really hard to assess how well our systems are doing. Ultimately, you want to hook this up to your users and either passively or actively harvest their feedback. So the simplest version of this, of course, is A/B testing. If you write many versions of a summary and you expose a large number of humans to A versus B, you can just find out what they think of it by, for example, whether they click through and read it. You can also make it active. You can let users say, yeah, that was good or that was bad.
Or going back to my Hemingway text summaries, Google Inbox presenting you 3 choices for how to summarize the appropriate response to an email. Yep.
And we've played with that as well. We generate alternative summaries to events, for example. It's a really powerful way of real-time, effortless quality checking. You don't want to have to sort of pause your whole engineering operation in order all the time just to assess how well you're doing. You really want it to be sort of continual. You want to always be reading the output of your own computational systems. We call it dog fooding. If you got to be real-time dog fooding. And so the nice thing about Primer Science is this thing that I'm building is we use it to discover the research that is going to help us make it better. Right. And so if you keep on using the thing, you are your own quality assessor. That really helps.
Right.
But hard to scale. I wish I could clone myself in some way to assess sort of at 1,000x.
Now, one thing that I didn't see in what you've built, it seems like it does a really good job at kind of this meta characterization of archive and what's happening in different categories. But I didn't see it attempting to summarize individual papers, which is the thing that Jeff Dean and I were originally talking about. Is it trying to do that somewhere?
Not in what you're looking at. We are actually working on that summarization problem.
Okay.
Yeah. So we've taken 2 strategies, and they're kind of running in parallel. One is extractive summarization, where the system is allowed to pull words and even whole sentences directly from the text and then kind of pull them together into a summary. That works extremely well when you have a large number of docs. Like if you have 100 documents all about the same thing, extractive summarization is really powerful and really efficient. And then the alternative is abstractive summarization, where the system is going to write its own words, often character by character, out of thin air. And it has a language model. So it reads all these things and it basically makes a prediction about what it should say next as it generates a summary. A really nice bit of progress in this field that we've been using is abstractive summarization with pointers. So the idea here is you also have a sense of your confidence about whether the word or phrase that you're putting into the summary at any given time is going to be a good choice. And if you're not so confident, you point back to the text and you grab the thing itself. So, for example, if you had a sentence that said, one of the most exciting areas of artificial intelligence these days is generative adversarial networks. Now, if generative adversarial networks, that phrase, is something that you haven't encountered, or your model basically says, I'm not sure if I can actually paraphrase that, then what you want to do is what a good human writer would do. You just go back and you grab that thing. So you can summarize while also having some of the advantages of extractive.
So summarizing basically around the entities that you aren't too sure about.
Exactly. it basically becomes a sliding scale between abstractive and extractive. The more confident it gets, the more abstractive it gets, the more flexible it gets, which will allow you to summarize a single scientific paper, for example, in a couple of sentences. And if you're not so sure, then it slides over to extractive, and it will just pull out the sentences that it and the phrases that it deems are the most central and informative.
Interesting.
It's a hard problem, though. It's a really hard problem. Another thing that makes it hard when it comes to scientific papers is they already have their own summaries. They're called abstracts. And you'd think that, oh, great, job done. But as you know, abstracts themselves can be so riddled with jargon and references to arcane things that it's hardly a summary at all. It's really only a summary for the authors of the paper.
Right.
So you really need a summary of the summary.
Right.
And that's what we're working on. We're finding that you really do need to power this with an ontology and a knowledge base, though.
Elaborate on that.
Okay, so let's take, for example, a problem that I'm just starting to work on. How do you summarize and make sense of pharmaceutical research papers? So there is an ontology that is available to everyone that basically the NIH paid for, called MESH, and it's kind of like every jargon term in biochemistry and molecular biology, gene names and gene types. All of that is captured in this very rich ontology that was hand built no doubt by unthanked graduate students. And something that's really nice about MESH is that it's actually a subset of Wikidata. And Wikidata is the database that stands behind Wikipedia. Now, I say that in an idealistic way because actually, in reality, that's the way it was dreamed up. Oh, Wikidata is going to basically be the database that powers Wikipedia. But in fact, it's not there yet. Humans vastly prefer to update Wikipedia with content, and Wikidata basically plays catch up. Nonetheless, it is a huge, powerful open source knowledge base, and the MESH ontology is a subset of it. And so if you want to summarize a scientific paper, just a single scientific paper, the first thing you need to do is make sense of it. You need to map all of those words, which to the computer are it could be random numbers for all it cares. It has no idea what it means. You need to map them to concepts. And that's what systems like MESH were designed to help us do.
So the idea being, instead of what you're doing in Science Primer and doing this in a totally unsupervised manner, here you're using the additional information you're getting from the pre-existing ontology to help the machine make sense of the various documents.
And to paraphrase it. So like a good summary is something that doesn't just like say less. It also says just as much, but in a compressed way.
Right.
If I just tell you the beginning of a story, I haven't really compressed that story for you. I need to like give you the sense of the beginning, middle, and end, and compress that all down into 3 sentences. And you're not going to be able to do that just using the standard NLP techniques on a scientific paper. You're just not going to be able to do it. No way.
Right.
You have to map that out to an ontology and say, oh, this long sentence describing this genetic pathway, I can boil that down to a single sentence that says the genetic pathway X.
Interesting.
But yeah, you need a lot of tacit knowledge to be able to do that. So that's what we're working on.
Awesome. Well, John, this has been super interesting. I really appreciate you taking the time.
Thank you.
Anything else you'd like to share with the audience?
Oh, just that I'd like to make a prediction.
Go ahead.
Well, I predict that the kind of stuff we're working on is going to accelerate artificial intelligence research more than anything else. I think building AI that can read the latest research on AI and help the engineers who build it faster is going to vastly accelerate the whole process.
Awesome. Well, we will put your prediction on the blockchain and Just to make sure we get all the jargon in.
Exactly. Then we'll do an ICO.
And we'll do an ICO, right? Awesome. Thanks so much, John.
Thanks, Sam.
All right, everyone. That's our show for today. For more information on John or any of the topics covered in this episode, head on over to twimlai.com/talk/136. Thanks so much for listening, and catch you next time.